So today we are in Unit 4, Lesson 1, Basic Identities. Our learning targets. I can use the Pythagorean identity to solve for the unknown sine or cosine value. And I can verify identity using basic definitions of trig function and using Pythagorean identities. So a trig identity, what is that? It's an equation involving the trig functions that holds for all values of the variable. So let me show an example. So this sine squared theta plus cosine squared theta equals 1. That's a Pythagorean identity. It's like a squared plus b squared equals c squared. It's in that same form. So let's go ahead and let me just show you for one value of how this works. It's going to hold true for every single value on the unit circle. So at pi over 6, on the unit circle, it's right here. All right, so when theta there is pi over 6, we end up there with the ordered pair there of square root of 3 over 2 and 1/2. So we're going to plug those values into the sine squared theta plus cosine squared theta equals 1. So if I plug that in there, you get sine squared, and then theta there we said is pi over 6, plus cosine squared of pi over 6, and that's supposed to equal 1. All right, so it's the same thing as saying the sine of pi over 6 squared plus the cosine of pi over 6 squared equals 1. So what is the sine of pi over 6? So if you remember, on the unit circle, your sine of whatever angle you have there is your y value. And your cosine of whatever angle you have on the unit circle there is equal to your x value. So in our case here at pi over 6, the cosine of theta there, the cosine of pi over 6 there is a square root of 3 over 2. The sine of pi over 6 is my y value, which is 1/2. All right, so the sine of pi over 6 is my y value, which is 1/2. The cosine of pi over 6 there is the x value at that place, which is the square root of 3 over 2. And now I'm just going to complete my math there on the left-hand side there. So 1/2 squared, 1 squared is 1, 2 squared is 4, so I get 1/4. Square root of 3 over 2, if I square each of those, the square root of 3 squared is 3. If I squared 2 there, I end up getting 4. So then 1/4 plus 3/4 there is 4 over 4, because you add your numerator, write down the common denominator, and 4 over 4 reduced is 1. So that does hold true. And if you did any ordered pair there on the unit circle and you plugged them in there, in sine squared theta plus cosine squared theta, you are going to get 1. So now I'm going to derive this Pythagorean identity, sine squared plus cosine squared theta equals 1. And to do so, I'm going to use the equation of a circle. So the equation of a circle goes x minus h squared plus y minus k squared equals r squared, where hk is the center of your circle and r is the radius of your circle. So our center of our unit circle happens to be 0, 0. And our radius of our unit circle there is always 1. So I'm going to go ahead and substitute those in there. So hk there is 0, 0. So x minus 0 plus y minus 0 squared equals r squared. Well, x minus 0 there is simply x, so you just get x squared. Y minus 0 there is just y, so you get y squared. And 1 squared there is simply 1. Well, on the unit circle, let me kind of draw a picture out here for you. Here's a unit circle. Here's this. You remember, if I go from here out to here, the ordered pair sitting here is 1, 0. So you can tell that this distance in here is 1. And if I do that anywhere in here, up to here, remember the ordered pair here is 0, 1. Well, this distance in here is 1. And anywhere in here on the unit circle, you're going to find that the radius anywhere on here is 1. These are all 1s. So that's why our radius there is 1. And then, of course, it's centered here at 0, 0. And that's why the center of the circle there is 0, 0. So I also wanted to remind you here, like these ordered pairs that are out here, remember every single ordered pair. So let me draw out a little triangle here for us. Going over so much and up so much to get there. So we're going over x on the unit circle and up y. So you're going over x and up y. So if you remember on the unit circle here, our x is the same thing as our cosine of theta, and our y on our unit circle is the same thing as sine theta. So to do so here, we end up there getting cosine theta squared plus, now I'm just substituting this in here and substituting sine theta in here for y. Sine y equals 1. Well, then we can just rewrite this. I'm going to switch the order here, and I'm going to put the squared where we usually put it. So the shortcut way of writing this is sine squared theta plus cosine squared theta equals 1. So that's the formula. You're going to see this Pythagorean identity all the time, and you're going to be using it. So let's look at this first example here. It says use the Pythagorean identity to solve for the missing sine or cosine values. So if you have one on the unit circle, you can find the other. So this one says if the sine of theta is equal to 3/4, so that's not one of our known ones. So let's use our Pythagorean identity there to find the cosine. So if I got sine squared theta plus cosine squared theta equals 1, I can plug my sine value in there and square it. So if I square both the numerator and denominator, I get 9/16. Now I can subtract 9/16 from both sides. So I get cosine squared theta equals 1 minus 9/16. So I'm going to get a common denominator, which is 16. So if I subtract my numerator there, 16 minus 9, there's 7 over the common denominator of 16. All right, so now to solve this, I'm going to have to go ahead and take the square root of both sides. And when I do that, I get a plus or minus here on the outside. So I get the cosine of theta is equal to plus or minus, the square root of 7 is the square root of 7, but I can find the square root of 16 down there, which is 4. So I get plus or minus the square root of 7 over 4. But they gave us another indication. It says that theta is in the first quadrant. So if we're in the first quadrant, that's over here. In the first quadrant over there, sine and cosine over here, every single ordered pair that's on our unit circle over here in this quadrant over here, it's always going to be a plus and a plus. So we know that the cosine there has to be a positive value. So we're going to say the cosine of theta has to be a positive square root of 7 over 4, not the negative. A bit. All right, let's look at another example. Again, it says use the Pythagorean identity to solve for the missing sine or cosine values. So again, I'm going to use my Pythagorean identity there. I'm going to write it out. So I've got sine squared theta plus cosine squared theta equals 1. We don't know sine this time. Cosine is -1/4. So if I go ahead and square both the numerator and denominator, negative 1 squared is 1, 4 squared is 16. I'm going to subtract 1/16 from both sides. Get a common denominator over here, which would be 16. So 16 minus 1, there's 15 over the common denominator of 16. So now what do we have to do? We have to get rid of squared, so we need to solve for sine. So I have to take square root of both sides, so I get a plus or minus over here. And so we end up here with the sine of theta equals plus or minus the square root of 15. The square of 16, there's 4. All right, so now which quadrant are we in? It says in the problem up here, theta is in the third quadrant. So let's come over here and let's draw this out. This is quadrant 1, this is quadrant 2, this is quadrant 3. Down here in quadrant 3, it's a negative and then a negative. So since we're in quadrant 3 down there, both sine and cosine are supposed to be negative. So the sine of theta is negative square root of 15 over 4. All right, so there are some reciprocal identities. Cosecant is 1 over sine. Secant is 1 over cosine. Cotangent is 1 over tangent, which is the same thing as cosine over sine. And tangent is simply sine over cosine. So our Pythagorean identity here is sine squared plus cosine squared equals 1. We can rewrite this and solve for sine squared. So I can do that by subtracting cosine squared from both sides. So we end up there with sine squared is equal to 1 minus cosine squared. So we can also, I'm going to rewrite this again. Sine squared theta plus cosine squared theta equals 1. I can also solve this for cosine squared, so I can get rid of sine squared. So I end up here with cosine squared theta equals 1 minus sine squared theta. So it's nice when you have these because sometimes you have to replace later on. You're going to be replacing sine squared there with 1 minus cosine squared theta, or you might have 1 minus cosine squared theta and you have to replace that with sine squared theta. And the same thing with the other formula. You got cosine squared theta is equal to 1 minus sine squared theta. You can replace any cosine squared theta with 1 minus sine squared theta, or you can replace any 1 minus sine squared theta with cosine squared theta. And that's helpful to know. Because what we're moving into here is proving identities. So you want to pick the side of the equation you wish to work with and then write it down. So you're going to have a left side and a right side. So you'll say something is equal to something, and you have to show that one side is equal to the other side. So you want to just work on one side until it ends up being the same as what's on the right side. Or if you work on the right side, then you want to show that equals the left side. Typically, I work on the left side and get it to look like the right side. So sometimes one side is more complicated than the other. So maybe you want to pick the easier side to start with, but sometimes one side is so easy that you don't know what to do with it. So you might want to pick the complicated side. So some things you want to look for. There's some algebra things to do, like maybe you can add some fractions together, or maybe you need to get a common denominator because they're fractions and then add them together or subtract the two fractions. Sometimes it's a matter of factoring something out, like they have a sign in common, so you might want to take the sine of theta out in each case. Sometimes they want to multiply by the clever form of 1, so maybe you need to multiply the numerator and denominator by its conjugate, or or do any obvious algebra things like you want to use a distributive property, or maybe you have to square both sides, or maybe you have to multiply two terms there together. We can also look for some trig things to do. So like replacing, like I was saying before, if sine squared is equal to 1 minus cosine squared, then you can replace the 1 minus cosine squared theta with sine squared theta. Or maybe you've got a cosine times secant, and you can replace the secant with 1 over cosine. Or maybe you've got sine over cosine, and you can replace that with tangent. So you're going to look for similar trig expressions there so that you can replace them with something else. If there are squares of functions, think in terms of Pythagorean properties. So if you see a sine squared or a cosine squared, and you see the other side has to have a subtraction sign, then you might want to replace the sine squared there with 1 minus cosine squared because the other side has a subtraction sign in it. Maybe you want to reduce the number of different functions by transforming the ones that you have there into the answer there. So keep looking at the answer to make sure you're headed in the right direction. So always look at the other side to see, am I getting there? Is it starting to look like that? What do I need to do to make it look like the other side? All right, so these are what we're going to be working here. So you see it says verify the identity. So we have cosine theta times the parentheses secant theta minus cosine theta is equal to sine squared theta. So I'm going to work here on the left-hand side to get it to look like the right-hand side. All right, so I'm not going to keep writing equals down. I'm just going to work on the left-hand side and get it down to say sine squared. So my very last statement down here should say sine squared theta. That's what I want. All right, so looking here, what could I do? Well, I could use a distributive property. That's an algebraic thing to do. So I'm going to use the distributive property and distribute cosine through. So we've got cosine theta times secant theta minus cosine theta times cosine theta. All right, so now what I can do. So I'm supposed to get it down to sine squared. So it doesn't have any secants in it, so maybe I'm going to change this into cosines. So secant is the same thing as 1 over cosine. So I'm going to replace that secant there with 1 over cosine. Over here, I can just multiply these two here together. Cosine times cosine there is cosine squared. All right, so this is like over 1. So cosine times 1 over cosine, multiply my numerator, multiply by my denominator. So I'm doing another math thing. So I get cosine theta over cosine theta minus cosine squared theta. Well, cosine divided by cosine there is 1. All right, but remember what I told you before, and you might want to write these down someplace. But we said that cosine squared theta is equal to 1 minus sine squared theta. So I'm going to replace this with 1 minus sine squared theta. Now, why am I doing that? Because I need to get down here to sine squared, and I don't have anything to do with sine in my answer at sine squared at all. So if I substitute 1 minus sine squared in there, I will start to get a sine squared in my answer. So 1 minus sine squared. And I'm going to move this because now it's going to hinder my progress here. So I know that's where I have to get. So now I'm going to use my distributive property and distribute the minus sign through. So I get 1 minus 1. A minus there becomes a plus. So again, doing an algebra thing, distribute the minus sign through. And then the 1 minus 1 goes away. And I'm left with sine squared, which is exactly where I needed to go. So that's what we're going to be doing for today and next couple of days here. We're going to be looking at these verifying identities. So let's try another one. So we've got secant squared theta minus tangent squared theta equals 1. All right, so let's work on the left-hand side here. So secant squared there is the same as 1 over cosine squared. And a lot of times I like to say that I'm working on the left-hand side, so it stands for left-hand side. You don't have to do this, but it makes it really easy for someone following this to see that. Tangent is, remember, tangent is sine over cosine, so tangent squared is the same thing as sine squared over cosine squared. Right? I'm not going to write down equals 1. That's what I want to get down to. My final answer down here is going to be, I'll write it down here, equals 1. All right. So now see, we have a common denominator there, so now I can write it as a single fraction. I can do 1 minus sine squared all over cosine squared, because I've got a common denominator there. All right. What is 1 minus sine squared? Well, do we have anything that's 1 minus sine squared? Yeah, we do. Do you remember what that is? Yeah, 1 minus sine squared. Remember, we had back on the other page there, we said that's the same thing as 1 minus sine squared. Cosine squared is. So I can replace that 1 minus sine squared theta there with cosine squared. And what's cosine squared divided by cosine squared? It's simply 1. And that equals the right-hand side. So you'll see that in my answer key that I'm constantly saying it's equal to the right-hand side. So I put that on there for you. Else, if you don't remember that, if you don't remember this, you don't have it written down someplace, you can always do this too. Sine squared theta plus cosine squared theta equals 1. You can see the 1 in this step right here. So another thing you might have done here is you might have replaced the 1 with sine squared theta plus cosine squared theta all over cosine squared theta. Well, then sine squared minus sine squared is gone. So you end up with cosine squared theta over cosine squared theta, which is 1. So again, you might have done something a little differently there, which is fine. It's just, and something you notice. All right, so we've got another identity here. It's cosine squared theta minus cotangent squared theta equals 1. So again, we have to get this down to 1, so let's change these. We know that cosecant theta is equal to 1. Cosecant is the same thing as 1 over sine. So I'm going to say left-hand side equals 1 over sine squared. Cotangent is cosecant over sine, so it's cosine squared over sine squared. All right, again, we're not writing down the 1. Notice it already has a common denominator, so let's put this together with this common denominator. We get 1 minus cosine squared theta. Don't skip steps in here. Make sure you're writing out each step individually. It's very important. All right, so now you decide what to do here. If you know that we've already rewritten this before, we said that this is the same thing as cosine squared theta, right? So we can replace 1 minus cosine squared there with sine squared. And then that gives us 1, which is the right-hand side. So it does work. Again, though, if you don't notice this, but you know this, sine squared theta plus cosine squared theta equals 1, at this point here, we could have done this instead. We could have replaced the 1 there with sine squared plus cosine squared, and then minus cosine squared all over sine squared. So then what happened up there in the numerator? The cosine squareds went away, and we end up there with sine squared over sine squared, which gives us 1. All right, our next example there. So verify this identity. We've got sine x times secant x all over tan x is equal to 1. All right, so again, I'm going to work there on the left-hand side to get it to look like the right-hand side. So I want to get it down there to a 1. So my very last statement down there is going to equal 1. So I'm going to work on the left-hand side. So sine, don't really know what to do with just a plain sine, but I can change that secant into 1 over cosine. Tangent, I can change that into sine over cosine. All right, and I'm going to put this over 1. So up there in the numerator, I'm going to multiply sine over 1 times 1 over cosine. So sine times 1 there is sine x. 1 times cosine x there is cosine x. And then the denominator down there, I'm going to leave it. Don't skip these steps here. You've got to make it obvious. All right, so my next step here. I'm going to change this into right now it's a division problem. I'm going to change this into a multiplication statement. So I can multiply by the reciprocal. The reciprocal is cosine x over sine x. So then, of course, you get sine x over cosine x, which then hopefully you can see that they're going to all cancel out there. So I'll write it down here. So you can see that basically these are going to cross out here. And so you get 1 over 1, which equals 1, which is the right-hand side. So you want to write things out. We went from division to multiplication. It got 1 over 1, which gave us 1, which is the right-hand side, and we're done. So verify the identity. Secant squared x minus 1 all over secant squared x is equal to sine squared x. So let's start on the left-hand side. All right, so something we might want to do here is to separate this. So we've got secant squared x minus 1 all over secant x. So maybe we want to take the first term up there in the numerator and put it over the common denominator. And then take the second term over there, put it over the common denominator. All right, so secant squared x divided by secant squared x is 1. And over here, I'm going to change that, since I'm trying to get the sine squared, I'm going to change that secant squared into 1 over cosine squared. Right? Secant squared is 1 over cosine squared. All right, so we've got 1 minus, I'm going to change this confusing fraction over here because you've got 2 division bars. You've got 1 here and you've got 1 down here. So I'm going to change this into a multiplication statement. This becomes 1 times the reciprocal of what's down there in the denominator, which is cosine squared x over 1. Okay, so if I multiply that, I get 1 minus cosine squared. So then, again, if you can recognize this, sine squared is equal to 1 minus cosine squared. You might want to write that down someplace so you have it in your brain. The other thing you can do is replace 1. We know that sine squared x plus cosine squared x is equal to 1. So at this point right now, I can either say it's equal to sine squared x, because we know that by now, and we're done. Or again, I can take this and put it in there. And if I do that, the cosine squareds will cancel out and I'm left with sine squared. All right? Your turn. So I want you to pause the video and see if you can try this one, and then I'll go through that for you. All right, so this one here, example 7, verify the identity. Sine theta plus cosine theta times cotangent theta is equal to cosecant theta. So again, I like to work on the left-hand side. So I've got sine theta, can't really do anything with that right now. Can't really do anything with cosine theta. So I'm looking at that cotangent and thinking, oh yeah, I can change that. And cotangent is the same thing as cosine over sine. If you don't know these, you need to write it down. So maybe someplace you've written down that cotangent is equal to cosine theta over sine theta. All right, so what can we do next? We're going to combine these over here. So we've got sine theta, can't do anything with that. But over here, I can multiply my numerator and denominator, and I get cosine squared theta over sine theta. All right, so the only thing I can think of right now is I'm going to need to get a common denominator because I've got a denominator. The second term there has a denominator, and the first term does not. So I'm going to get a common denominator. My common denominator is going to be sine. So this has got to be sine theta. And up here, I'm going to have sine theta times sine theta. So that really gives me sine squared theta. All right, so now we got a nice common denominator, so I can go ahead and put it together over one denominator. So I'm saying sine squared theta plus cosine squared theta all over sine theta. And what is sine squared theta plus cosine squared theta? That's 1 over sine theta. And what is 1 over sine? You remember, cosecant theta is 1 over sine. So that gives me cosecant theta, which is my right-hand side. And so I'm done. Again, you've got to know what these are here. You need to know those. So if you don't, write them down so you have them on a sheet of paper. So I can use that Pythagorean identity to solve for the unknown sine or cosine value. So we use that sine squared theta plus cosine squared theta equals 1. And then I can verify identity using basic definitions of trig functions. So that's like your secant is equal to 1 over cosine and using the Pythagorean identities. So you're going to work on your 4-1 worksheet.